Okay, hello. I am Rafał Pocztarski, and recently some of my friends told me that they follow the technologies that I follow because I happen to jump quite quickly in some technologies like, I don't know, JavaScript in '96 or Node in 2009 and Deno in 2018. So they often ask me what I am looking into now, so they can prepare to new stuff. And I wanted to not make any spoilers in the promotion of this presentation, so hopefully no one knows really what I will be focusing on today. You may know me from Stack Overflow because I'm quite active there, so but I guess that's enough about me. Who's heard about WASI? Okay, I see two people. Okay, so this is actually a kind of a helper to know what I'm talking about, but this is a quote. I guess everyone is familiar with Docker, but maybe not everyone knows the name of Solomon Hykes, the founder and CTO of Docker. And recently, few months ago, not even a year ago, he said that if something that I will be talking about today and WASI existed in 2008, he wouldn't have needed to create Docker. And this is how important this technology is. So I don't know if anyone could guess what is X here and what I will be focusing on, but probably not. But I guess that we should be all looking into it, because if Solomon Hykes is saying that actually Docker would not be needed if it was ready earlier, then I guess this is something important. And this X is actually WebAssembly. This may be more familiar name for any of you than WASI. And this is the actual quote. If later at the end of the presentation you will get the link, the URL to the slides, so you will be able to click the links to the original post on Twitter about it. So what is WebAssembly? WebAssembly is a standard which is actually the name is quite strange, because this is actually a binary format mostly, and not an assembly language like you would might guess from the name. The actual text format is called WAT, which was a spoiler on this actually slide. So WebAssembly is a standard that lets us write web applications in a language, in any actually language different than JavaScript, without transpiling it to JavaScript. So previously there were languages like CoffeeScript and other languages like ClojureScript, and actually a lot more that were transpiled to JavaScript, like TypeScript. But this is it is possible to, for example, transpile Python code to JavaScript, but then you run it using all of the JavaScript semantics and the garbage collector and all of the runtime. And WebAssembly is something that lets us run code written in other languages in nearly native speed. So this runs almost as quickly as, for example, C++. And actually you can write C++ and compile it to WebAssembly. WASI is a new standard. It's WebAssembly system interface that is needed to write standalone applications that can access, for example, file system and other usual things that standalone applications access. So not only for web applications, but for standalone applications for servers and things like that. This is a very fresh thing. There is a WASI dev website that you can get more information. Maybe some of you is familiar with ASM.js. This is an older standard that were used by compilers like mscript10 to generate actually JavaScript, but annotated with things like for example bitwise operators that is like OR with 0, that is a no op because it doesn't do anything, but it gets a hint to the compiler or the optimizer that the number will be integer, so it can generate faster code for it. But it was not it actually was possible to compile big applications, but it was not very performant. It was faster than pure JS, but WebAssembly is something newer. WebAssembly Studio is something that is not very popular. It's hard to find. I guess everyone should start from there. This is something like CodePen, but for WebAssembly, like CodePen or JSBean or JS Fiddle, that you can actually write programs in C++ or C or Rust or actually manually by the textual representation of WebAssembly in the browser. There is an online IDE. You can write that code, you can compile it, you can download the binaries, and you can even disassemble the binaries that are generated there so that you can see the textual representation of it. One of the questions is if we can already use it, because it's quite a new technology. It's not very well known, but actually it's quite well supported in a lot of browsers. And in Poland, it's like 92% of the traffic is based on the statistics of the browser that I used are already support WebAssembly, so we can today write web applications not in JavaScript but in Rust or in C++ or in I don't know in Smalltalk or Haskell, and not do it in a way like we do with ClojureScript or TypeScript, that it actually gets transpiled to actual JavaScript that is run on the browser, but to generate a binary WebAssembly code that is then downloaded by the browser, and a very fast native machine code is generated from it, and this is what gets run. It differs from running JavaScript in a way that when you download a JavaScript program, then it has to be compiled very fast, so that we don't wait a lot before starting the code, but then we don't have time for a lot of optimizations. So it actually works like this, that when JavaScript programs run in a browser, they start as fast as they can, but then some statistics are gathered to see if some parts of the code are invoked more times than others, and maybe it's worth to optimize it, and then the optimizer kicks in and there's a JIT compiler, the just-in-time compiler, that generates faster versions of the code for some parts that are used more frequently, making some assumptions, because JavaScript doesn't guarantee, for example, shapes of objects. Like I can have a million objects that has the same properties, but then another one might come in with some missing property of some additional properties. So actually sometimes it needs to be de-optimized because the assumptions turn out to be wrong. But with WebAssembly, the compilation gets done once before it's actually shipped to the browser, so we can optimize it heavily. We don't have to worry about longer time of compilation, because we do it once during the build time of our application, and then the application gets the compiled version in the WebAssembly standard. And it's important that it's not a machine code for any given architecture, because we might be running the website in different operating systems on different CPUs, so it will be impossible to generate a machine code for all of those architectures. Even differences like different Intel processors can have different instruction sets or have different bit width, so that there are 64-bit CPUs, 32-bit CPUs, so the code must be very universal. I see that we are getting low on batteries, so I don't know if maybe there is some okay, I know it seems that it's charging, but I don't know how it's.
Uh-oh.
Maybe I have too high resolutions on my slides. So.
Cool. Not charging. Let's assume all is going to be good.
Okay. It's always a good assumption in web development, I guess. Okay, so this is I don't know if probably you all know the Can I Use website, where you can see all of the things, and there is WASM in Can I Use, so you can see exactly which browser and which version supports it and to what extent. And actually WebAssembly 1.0 has shipped in 4 major browser engines, so there is a roadmap on the webassembly.org website, so you can see that all of the browsers reached consensus and agreed on some of the features in 1.0 version, and so this is actually like it's not the final version. I hope that there will be more extensions to WebAssembly, but currently it's already working, and you can even use it using the WebAssembly Studio without even installing any tools on your own computer. So you can write C++ program on the screen. It will generate you a real compiled WebAssembly binary that you can use on your own website, in your own project. You don't even need to install your tools. There is so usually the main idea was that WebAssembly binaries are run in the browsers. But there is an interesting standalone runtime for WebAssembly and WASI, and actually the WASI makes sense not in the browser because we don't want unrestricted access to file system, for example. And actually there is some interesting security thinking that was put into WASI standard, because it's based on a capability model where to open any file on the file system, you must provide an already open file descriptor that is like the root of your path that you want to open. So if for example the runtime gives you only access to a certain directory tree, then you will not be able to open any files outside of it. And it's just because that you must have the file descriptor, and you cannot really forge a file descriptor because it's just a single number, like probably the file descriptors like 0, 1, and 2 for standard input, standard output, and standard error streams. So you cannot really get to another process standard output because it just has the number 1 as well, so it doesn't give you anything. There's in the process table in the file system there is a mapping done, so you cannot really forge those file descriptors. And this WASM time is done by a bytecode alliance project, and it's an interesting project. I haven't heard about it until recently, so I don't know how old it is, but it's focused on building standards, building software and secure software, open source software, building it on standards such as WebAssembly and WASI, which is the WebAssembly system interface. There is a bytecodealliance.org website that is interesting to look at, and there is more runtimes, standalone runtimes for WebAssembly than that. There is on GitHub. This is actually a link, so if you open the slides later, you can click on it, but you can also Google it. It's the awesome WebAssembly runtimes repo on GitHub, where there are more links to other runtimes. So some naming conventions that may be useful to say. WASM is actually the WebAssembly binary format. So if you see a file with a WASM extension, this is a binary, so it's not worth looking into it unless you just want to look in binary representation of the code, which may be quite useful because this is quite an interesting format. What is actually what you would be writing by hand? So if you want to write in WebAssembly, then you actually don't create WASM file, a file with a WASM extension, but a file with a WAT extension. This is WebAssembly text format. And WABT is a WebAssembly binary toolkit. So those are the tools that you need to install if you want to compile or work with the WebAssembly locally, or you can use the WebAssembly Studio to do it online. Other tools are Mscript, that some of you may have already heard about, because this is the tool that was originally used a few years ago to compile some old games to run in the browser. So there were some examples on Quake running in the browsers especially when browsers started to support WebGL. Then it was possible to nicely translate all DOS games into browsers. So Mscript then was used. It's actually a LLVM compiler backend that was originally targeting JavaScript, then Asm.js, which is like an annotated version of JavaScript, and now it can output WebAssembly, which I've seen even Windows 95 entire operating system compiled into WebAssembly, and it's running in the browser. So you can Google it, and it's actually a working operating system that you have in your browser, and it doesn't even run very poorly. Of course, we have much faster computers today, but considering that we have an entire operating system emulated in the browser, then it's quite remarkable. The WebAssembly binary toolkit I was already talking about. I'm giving you the examples because if you want to get involved in WebAssembly, sometimes it's hard to know what tools do you need to do what, especially the confusion with the names that people think that usually it was the case that assembly, asm.asm files was actually text format that you wrote writing assembly. I know, just out of curiosity, has anyone of you been writing assembly languages, programming in any assembly language for one person, 2, 3, okay. So with me it's 4, I guess, so it's not very popular, but I guess that it might change when we start writing in WebAssembly, which is actually I will get into it later. And there is also another similar to WAPT, another toolkit. It's called Venerian. It's another toolchain. I think it's newer. There is EMCC. It works like GCC, so we can. This is actually from Mscript, and so you can. Like you use GCC to compile your C code, then you can use just EMCC and it compiles your C code, but it outputs WebAssembly instead of binary on your system, because GCC usually these days it doesn't output assembly language. Back in the days it was usually C compilers were usually outputting assembly, and then assemblers were assembling the assembly language to get binary code, but today usually they output binary directly. So Mscript then compiles C and C++ to JS, Asm.js, and WASM, as I said. And actually what's even more interesting is that it can compile any language that is translated into LLVM, so any language that is actually compiled with a compiler that gives the LLVM. Okay, I guess that your hope was not. Wow, this is nice. Okay, I hope you have more charged laptops going on, because this will take some time. Okay, so Mscript then compiles C and C++ directly, but it also can compile any language that is translated into LLVM representation. This is something like an intermediate representation for compilers. But also, oh, thanks. Okay, it's working. But also, what you can compile is not only your programs that you write, but you can actually compile the runtimes that you are using to run your programs. So, for example, if you are writing in Python or Lua, those are real examples that work like that, then you need some runtime. You don't compile of course you can, there are some projects for that, but usually when you write in Python on Lua, or then you don't compile your code for the architecture that you are running it on, but you are just using an interpreter that executes your code. So here you can actually compile the interpreter itself to WebAssembly. So you can, when you can run the Python interpreter in your browser, then you can run pretty much any Python program there. Of course, provided that the APIs that you are using are working. But there are a lot of use cases for that people are using in, for example, mobile applications or web applications, where they are using, for example, libraries for, I don't know, face recognition that are written in Python. They are transpiled into WebAssembly, so they can use them on their website to use if I know that there is some project to, for example, compress images like that. They compiled to WebAssembly some old, I think, JPEG compression libraries, so that, because currently you can, for example, if you are generating some images on the canvas, then you can save it to, for example, JPEG, but you have some control over, for example, quality of that, but you are stuck with the algorithms that are implemented in the browser, and you don't have control over everything. And also the browser doesn't support every format, so you can, for example, save, I don't know, JPEG, PNG, but probably not other formats that you might want to. But if you get an old library that is written in C that can generate any format that you like, then you can transpile it to WebAssembly and use it in your browser, and you can have anything there. So people are actually using it to use, instead of implementing things that are not implemented natively in the browsers or in JavaScript libraries, they use old C libraries or some Rust libraries to certain things that they can just run in the browser. And one of the nice side effect of that is that it runs usually faster, and that the performance is more predictable. So with JavaScript, it's often some engines, some algorithms run better with some optimizers, worse with other ones. They need to get hot to get optimized at all. They sometimes get de-optimized, so the performance in different browser, in different JavaScript engines varies a lot. But if it's compiled to WebAssembly, then usually it's pretty much the same in most of the browsers and in most of the time. So it's not only for performance, but also to get some legacy libraries that are maybe already developed, and you can use them today in your website. There is an interesting language called AssemblyScript, which is basically a syntax of TypeScript, but with types that are used directly in WebAssembly. Because I didn't say about it, but WebAssembly is a very low-level environment where you can have where you don't usually it doesn't provide any high-level data structures. You are basically dealing with a linear memory where you put integers and floats, and you can do anything you want with them. So you can use them to represent anything pretty much, because this is how actually normal CPU work. They also the CPU also understand mostly integers and floats, but all of other data types you can implement yourself, or you can use the compiler to do it for you. Because when you, for example, compile I don't know, C library, then you can have everything that C, for example, C strings work a certain way, and it just gets compiled, actually, and not transpiled this time, to the binary representation that is using the native data types that are available in WebAssembly to implement the types that you actually need. And AssemblyScript is interesting in a way that it gives us a very familiar syntax the TypeScript syntax, but it's not that you can run any TypeScript program and compile it with assembly script. You need to use the types that are native, like a 32-bit signed integer or things like that. So actually you don't have just a number like in TypeScript, and you can have full control what type of number, and that is, for example, an integer. It's an unsigned integer, and that is 32-bit integer. And when you write a program like this, then a very performant machine code can be generated, because the computer knows that it's not that there will be some other number there needed, because this is guaranteed statically before the compilation. So it's an interesting language. Today, actually, maybe I will say a few things about the talk today, because originally I wanted to give some focus on multiple technologies that I have on my mind today, and I noticed that preparing the slides and looking into some lectures and talks that I recently watched, and because there will be some more links at the end. I noticed that a lot, if not most of the things that I do in my spare time today that are not related to Deno or Node, that it's actually WebAssembly today. So it was so it was so much WebAssembly in this thing that I actually removed some of the things. And I actually regret that I removed HTTP 3, because there were 3 talks that you have mentioned HTTP 1.1, and another talk was mentioning HTTP 2, and it would be a nice addition if the 3rd talk was mentioning HTTP 3. Maybe there is some talk about it in the slide, because this is also an interesting technology that is quite recent. And some bonus of other things that maybe are under radar and not a lot of people are using it. For example, GitHub Actions. I don't know how many of you are already using GitHub Actions for things like CI. Not a lot of people. Okay, and I noticed that I stopped using, for example, Travis in my new project, because I can do anything that I originally did with Travis with GitHub Actions, and I don't need to have 2 accounts and switch between them, and so you can have GitHub run your CI, and it's free for public repos. You can run your tests on Linux, macOS, and Windows. And you can actually even run tests on your own machine. So you can register, you can have your own server or any computer. You can put a laptop with Windows in and install software from GitHub. And on every pull request, that computer will run tests, for example. And this is quite interesting, because it's often the case that, for example, I don't know if you are using Travis or Circle or Upway or any CI service, it's usually not very fast, because they are using quite slow virtual machines to run everything. It's run with Docker, and it also can slow down when a lot of people are using it at the same time. You usually only have one parallel job that can run at the same time, unless you pay for a higher plan. So of course you can have as many as you want, but then you can pay a lot for services like Travis or Circle. But here you can actually put your own computer, and what's interesting that you can configure it however you like. And they provide software for Linux, Mac, and Windows that you can just put your own computer that will something like today you would do with Jenkins, but without the overhead of configuring it. You just configure it with YAML configuration files in the repo itself, so like you do with Travis or Circle today. So this is, I think, worth looking into. I'm already using it in my projects, and I'm very satisfied with it. And CI is not everything that you can do with it. There's entire marketplace of things that are already there, so we can use. So I encourage you to look into it. Another things that I am looking into that are not yet ready. This is one of the things that I recently I'm looking into, is operator overloading in JavaScript, it would be very nice to implement your own, for example, numerical types, because right now if you want to implement your own types, then you have those strange syntax that you cannot, for example, use the normal operators. I can have an object that represents a number, but I cannot to get two of those objects and use a plus or minus or slash between them. And this is a proposal to make it possible. And what's not very optimistic is that last time I checked, it was to be presented at December meeting, so it is stage 0, so it's like going nowhere yet, but I guess that it will get some traction because it will make some interesting things possible in JavaScript. Maybe someday, I hope, maybe we will get proper tail calls in JavaScript, because currently I don't know what it's taking so long. And actually today in WebAssembly implementations are even forbidden to optimize it very well, because then there is a risk that the programs that take advantage of tail calls, I don't know if everyone is familiar with that, or this is about recursion, so that you can have like infinite recursion without blowing the stack. Normally when you invoke, when one function invokes another function, or even itself, then there is data put on the stack, that this is the structure of the managed by the operating system and the CPU, so that the function knows where to return when you actually return from the function. But when you use recursion, that you actually invoke the same function over and over again, then this gets the same data, so it could be optimized. And languages like Scheme did it so many years ago that it's really a shame that we still don't have it in JavaScript, because it's possible to write certain algorithms very elegantly having that. But currently there is another proposal, because the proper tail calls that would make it just work like in Scheme in the 70s was too much, I guess. So there may be another standard syntactic tail call, so that there will be a different keyword than return. It will be something like continue or something like that. So, but this is also something interesting, because having that. Actually, this is one of those features in the languages that I always tell people that to experiment with different programming languages, because when you don't have a tool at your disposal in the language that you are working in, then you don't actually know that you need it, because you don't express your algorithms in ways that could be used, because you just don't think that way. But then, for example, you get a languages like more functional languages like Haskell Scheme or something like that, or Clojure, and you see very elegant code that is impossible to write in JavaScript, just because we don't have the proper tail calls there. Maybe at least the syntactic tail calls will get somewhere. So this is something that I hope to watch this year, and maybe it will get somewhere. Quickly, I will get into the slides for some more info about things that I was talking about. About the WebAssembly and WASI. I encourage you, everyone who is interested, to watch like literally all presentations by Lynn Clark and Steve Klabnik. Those are excellent presentations, very informative, very interesting, very up to date. So this is, I think, and I usually like to start with watching a talk instead of reading documentation, because you can have some nice idea about new technologies, especially if you have no previous knowledge about WASI and WASM. So those are nice talks to start from. The TC39 is always one of the things that needs to be tracked, because most of the developers know. I hope that at least most know, for example, what is coming into I don't know, ECMAScript to 2020, or what was last year in ES 2019 and 2018 and 2017. But what gets into the versions of the standard is first discussed sometimes for years on the TC39 committee. So it's a technical committee of ECMA International. So if you follow some of the discussions, and actually there are those are usually GitHub repos, so you can have every feature that is, you can even propose your own feature to the language, and it's interesting that there is a discussion going on that you can discuss, for example, what would be, like we, for example, get the, I don't know, the REST operator for REST parameters, but we get it in the standard and we learn how to use it. But first some people were engaged in the discussion, how can it work, maybe there were different options to implement it, and some people who were up to date with the discussions by TC39 had a, you know, like a jump start to know about the features that were not even discussed in the versions of ECMA, of the ECMA script standard. Another thing is W3C, and actually the WebAssembly is not done by TC39, but in the communities of W3C. So those are some links to get more info, but those are some technical but interesting information. I will not go by it now, but when you maybe later would like to see the slides, that I prepared some the most interesting articles that I found. As you can see, most of them here at least are by Lynn Clark. So and there are people who are very active in the community explaining WebAssembly, WASI, and other related things. I put some links to the lectures that I encourage you to look at. Oh, actually, yes, there is HTTP 3 here. So. So yeah, we got 3 presentations with containing 3 different versions, consecutive versions of HTTP. So it's nice. So most of the things are about WASM, about WebAssembly. This is about HTTP. It's actually a very interesting implementation because it doesn't actually use TCP. So what we heard about the HTTP 1.1, that it itself uses TCP and it uses IP, then HTTP 3.0 doesn't use TCP. It uses a quick protocol which uses UDP underneath, so it's completely different. More lectures about WebAssembly, mostly about speed, some introductory lectures, also very interesting. And as you can see, most of them, those are in just last year. So most of the lectures that I'm preparing here are very new. I think maybe one of them was from 2018, and most of those are from 2019. So there's maybe a good chance that you haven't seen them. So also about WebAssembly and non-JavaScript languages, there are interesting talks about Rust, about ASP, about Go, and about Python. So actually those, for example, is on the Python conference or on the Go conference, and those are by people who are mainly developing, for example, in Python, and they see an opportunity to use WebAssembly to create, for example, websites in Python. So there are, for example, the one of those talks about ASP.NET is an idea to use the Blazor framework to create websites. So, for example, there are different UI frameworks in different languages like Smalltalk or Python or anything, and you can actually use them in the browser. So maybe the future will be like, you know, multilingual development on the front end. So currently the front end is mostly JavaScript, or at least languages that are transpiled to JavaScript. So you can maybe these days it's not as popular as it used to be, but you could use CoffeeScript, you could use of course TypeScript, and you could use languages like ClojureScript that get directly transpiled to JavaScript to do front-end development. But maybe in the future, maybe there will be a Rust web framework that is something like React or Angular, and not necessarily written in JavaScript. So we can, it's interesting to see how it goes. Of course, it will be a nightmare to later, have to maintain an application that is that has like different components written in completely different languages. It would be like today people are complaining when they have to maintain an application that has some parts of in React and other in Angular and something in Vue, but imagine that at least it's all JavaScript. But maybe a few years from now you will get a website to update and you will see, oh, it was written in Rust or in C++ or I don't know, in Haskell or Erlang or so maybe it's a good idea to look into other programming languages, like right now at least those that are aspiring to be compiled to WebAssembly. And this is something that I put today onto the slides because I was asking people at my work if they know what this would return. Anyone has any idea? So what would be maybe if someone thinks that is there anyone who thinks that there will be no three the same elements in the return of those expression? Okay, so I guess that maybe you have tried it, but this is an interesting example, so I thought that maybe I put it here because today at work a lot of people were like completely going crazy over it when I showed them. So you can try it. I will not spoil it to you, so maybe you will try it, and then later maybe you can try to understand why the output is as it is. And also because it's a nice recruitment question, so maybe it's... No, you don't think so? At least as an introductory, a conversation starter or something like that. Okay, so maybe there are some questions.
Gosia.
Ladies first, thank you, Kacper. Okay, so since you have already scratched the surface and you did regret removing bits on HTTP from your presentation, I wanted to ask you about exactly that. And I was wondering if you could explain maybe a bit more about this transition from TCP/IP to UDP, because I read somewhere that it's supposed to be not only faster, but also even more reliable. And as much as I understand it being faster, I don't quite get the reliability part.
Okay, so imagine that how TCP works is that it's using an unreliable IP protocol where you can have duplicate packages or packages not delivered, and so it is possible to create a TCP protocol that is reliable on top of an unreliable IP protocol. So it's also possible to build it on top of UDP protocol that is pretty much as reliable as IP. So by creating the things that we have seen on the previous talk, like the different ways to exchange packets, the sequence numbers of the packets. So you could implement something like the TCP, but instead of using IP, you could use UDP. So, but you need to create all of that, and this is the quick protocol that is used there. The quick protocol is like is using UDP like TCP is using IP mostly, and then over the quick protocol you can use another protocol layer like HTTP. So it is possible, and it is actually what's happening right now. So TCP is not like magically reliable. It needs to work with an unreliable lower layer, and this is pretty much the same you can do with UDP. I don't know if it answers your question.
It does, thank you.
Kacper?
Do you know about any use cases for WASI? I mean, when I have a program written in a C, for example, why would I want it to compile it to, or transcompile it to WebAssembly and run it using, yeah.
Okay, are you asking about program to run it in the browser, or
no,
a standalone program?
Yep.
Okay, so one of the advantages would be that you can ship a binary that is portable to add to different architectures, so you don't have to compile to every architecture, every operating system, because currently the target of the compiler. When you compile a C program, the result will be different on Linux, different on Mac OS, even for the same CPU. And for another CPU, it will be completely different. So you could have a portable binary format that is compact and created once and run on multiple platforms. This is one use case. But another use case is the security, because currently if you use a C program, if you write a C program and compile it directly to machine code, then it can access all of the system syscalls. And if it's not using some other abstractions, like for example Docker, then, or like jail roots or something like that, then you can, it's hard to control the resources that it can access. Here, you will be all of the API is designed in a way to have security in mind. So, and this is actually what the creator of Docker was talking about, that maybe Docker itself would not be needed if it was ready earlier, because those programs could be shared without containers running on the same machine, and with no worry that they could interfere with each other or cause any problems. So you could deploy a program that has access to only certain files or one directory and nothing else, and you don't need the container abstraction to make sure that it's enforced. But just by the way of the WASI, the WebAssembly system interface is working. So one of the things is security, another thing is portability, and performance is it's actually pretty close to C++. So I've seen some benchmarks that like the same algorithm for doing something like I think it was like factorials or something written in JavaScript was running 2 times slower than in C++, which is actually, I thought that it will be even slower, but it's not like that. It's not an order of magnitude. It's just like 2 times slower than C++, but WebAssembly was like 10% slower than pure C++. So it's not a big overhead to have the security and portability, and also you could directly import it. Currently the imports are not working yet, but you could directly import the program in your on your website, for example, and use the same algorithm on maybe numerous operating systems. You don't know what browsers, what systems, or CPUs people are using, and it will just work. So it's a nice thing.
Okay, thanks.
I see some other questions there. So
Stash. Do you think WebAssembly runtimes are competitors to Deno?
In a way, they are, I think. And they are actually also competitors to other runtimes, like, for example, maybe Python compiled to WebAssembly run on one of the runtimes, maybe it will run better than real Python. But here, yes, I think that also even the security model is like something of a competitor to Deno. It's a different model. In WASI, you need a file descriptor to open other files. In Deno, you like currently at least you provide command line arguments to explicitly list the files that are there. But also this is something of a competition of. It's not like competing right now, but the ideas are like competing ideas, different ways to solve the same problem of security, and also since you will be able to compile other languages, then it's a competition to actually all runtimes that there are. Maybe it will be like in the future, maybe most of the languages will be compiled to WebAssembly, or maybe even runtimes like the Python runtime would be compiled to WebAssembly, and then normal Python programs will be interpreted by that. It's hard to tell, but I think it's interesting to see how it all how it follows from now. It's all very new. It's and also I see that most of the people here haven't heard about most of the technologies. Most of the talks are from like few months ago, so I encourage you to look at the talks, especially about security. There are interesting talks that you may find interesting.
Thank you, Rafał. Our time is running, so congratulations for the talk.